Thank you everyone for joining. It is my pleasure to introduce Dr. Genovefa Kefalidou. She's a lecturer in human-computer interaction and director of EDI within the School of Computer and Mathematical Sciences at the University of Leicester. Her research focuses on user experience, design, and evaluation of cognitive systems, intelligent service design, and human data interaction. Her research is applied in transport and healthcare and has a particular focus on designing novel, intelligent, personalized decision support systems utilizing ambient intelligence and mixed reality technologies that explore novel human-in-the-loop approaches for optimization, enhance UX and performance of AI-based systems and services. She is also a co-investigator and member of the management board of the Trustworthy Autonomous Systems Verifiability Node, where she looks on how trust enhances verifiable autonomous systems and service acceptance. She's also the Athena Swan lead and ethics officer at CMS. So thank you again, Genovefa, over to you.
Thank you very much, Anasol, for the invite. And thank you all for actually attending the talk this early Saturday morning. So as Anasol said, I'm going to be talking to you about how we bridged the gap between physical, digital, and virtual, giving you a couple of results from recent studies that we conducted within the context of mixed reality and virtual reality, which it occurred during the pandemic period. And I will share with you some insights, both in regards to results of some results of those studies, but also implications for remote working, remote learning, and research. My background is, as Anasol said, is in user experience, very much coming from a multidisciplinary background myself, and that involved human-computer interaction, computer science, systems engineering, and psychology, cognitive psychology. And my practice over my professional year so far has been very much on designing technologies, utilizing socio-cognition, and I'm particularly looking at technologies such as mixed reality and AI, and how we can enhance user experience in novel ways, but at the same time ensure or revisit, as well as I would say, the role that humans have when we interact with advanced technologies such as artificial intelligence and mixed reality. Now, we all know that mixed reality, and virtual reality particularly, has been utilized in the past decades, because it's not really a new technology, it's a revisited technology. It's been used in many, many different contexts, in many different applications and experiential situations. So we have been using virtual reality for entertainment, for leisure purposes. We have been using virtual reality for designing simulations that they have applications in the medical field. We have been seeing advancements in the hardware and peripherals that are associated to virtual reality. So we've been seeing a massive change on the volumes and the number of peripherals virtual reality applications incorporate. So from having really room-sized and very cumbersome, let's say, peripherals for virtual reality, we have moved to something very, very much neater. As for example, we've been seeing Oculus Quest advancements. And of course, part of the mixed reality realm, where in effect we combine different technological aspects in enhancing the experience between the physical, the digital, and the virtual. We've been seeing, again, revived technology innovations such as Pokemon Go, which again is primarily used for entertainment and leisure purposes. So In the context of applications, we've seen that virtual experiences are heavily applied for training purposes, but also for play. For example, the picture that I'm showing you here is of myself and a colleague back in 2017, where we have been showcasing innovations that we've been introducing as part of one of our European funded projects back then called PASME, where in that particular project, I utilized virtual applications in order to help me design innovations, not just, for example, providing innovative experiences to the public. In our case, within the PASME project, the case was providing innovations to passengers at airports, but also I've been utilizing virtual technologies in order, virtual environment technologies, virtual reality technologies to help me design as well. So we've been seeing a quite wide adoption, different ways to capitalize on the innovations that virtual reality and mixed reality more broadly innovations offer to us. Now, one of the key things, speaking about user experience, one of the well-known investigations, interests that those of us that are involved in virtual reality research are interested in is the relationship between what we call presence, the feeling of presence, the sense of presence, emotions, and more explicitly, immersion. So a lot of research within the field has been looking at how emotions influence the sense of presence that people have when they are immersed, when they are being engaging with virtual reality technologies. So typically speaking, we witness a heightened sense of emotions because participants are feeling high levels of presence when they are immersed within a virtual environment, within a virtual reality experience, and vice versa. So we see a cyclic kind of interaction between presence and emotions. That's something that we wanted to explore further in the context of the example studies that I'm going to be talking you now. Immersion, which is, as we said, related or to presence and emotions, as we've seen here, can occur, is influenced not just by the emotions that someone exhibits when they are experiencing such technology, but also we have immersion that is manifesting, is dependent on the quality of that technology. This is one of the reasons why designing virtual reality applications and mixed reality applications more broadly is quite critical, because the quality of the design of those technologies affect how immersive, how immersed the experience of a user is. At the same time, we also have immersion types that they are manifesting because of the way that users are feeling presence within the virtual environment, within a virtual, let's say, context. Another layer of immersion is because of the way that we communicate information, messages, and experiences as well when people are immersed within an environment, a mixed reality environment. And lastly, we have immersion levels that are influenced by the way that people interact with, for example, a virtual environment within a virtual context, and of course, the challenges that are presented as part of this experiential engagement. one of the major context or also stimuli and setups that are heavily used in virtual reality research is what we call escape rooms. So I'm pretty sure some of you have heard of escape rooms. Perhaps some of you have experienced escape rooms. Typically are very much used for entertainment, leisure purposes. They are also being used as part of bonding exercises in management teams, and of course, within the context of training. So typically speaking, escape room is what the name suggests. It is an environment where people are being given a number of different tasks and there is a specific goal to follow. The goal usually involves escaping the room successfully. Now, within that kind of setup, within this kind of experience, there needs to be a set of different tasks that need to be performed. Usually, escape rooms is a collaborative environment. So typically there is a team that needs to collaborate with each other in order to perform, to complete a goal, to escape the room. There are some cases where we have also one-player games, where in effect there is no team collaboration, but there is only one single goal that a one player needs to perform in order to achieve something. Now, within this kind of context, of escape room context, typically speaking, part of the activities that users, people that are told that are engaging with their environment need to do include solving puzzles, and also include immersing, in effect, into a storytelling and narrative type of context, where they need to listen to something or they need to read something in order to complete the puzzles, in order to help them to complete the puzzles. So within those contexts, players are seeking an immersive experience which can actually go different ways. It can involve a number of different emotions, excitement, for example, anger, frustration, fear, and so on. So in effect, escape rooms as a setup provides an excellent way to test bed, to investigate user experience and emotions, particularly within the context of virtuality, as we say. So we've seen those kind of contexts, virtuality experiential contexts of commercial escape rooms being available throughout countries. And within the UK, we do have, for example, the reality experience in Leeds, but also we have a number of different VR escape rooms in London and in other big cities in the UK. Now, all those environments, the key thing that they're trying to employ is capitalizing on the different sensory input that we have. So accommodating different ways for people to interact with the virtual environment, including tactile, for example, touching the environment, holding additional artifacts such as torches, providing haptic feedback when people are navigating through the escape rooms, but also accommodating additional sensory input and sensory triggers such as hear, smell, temperature as well. In that way, designers of these environments are aiming to provide a more naturalistic experience for people that are immersed within these mixed reality and virtual environments. This is something that we wanted to explore in the examples that I'm going to be talking to you now. So what I've been doing with my colleagues and with Victoria, particularly, one of my PhD students, Victoria Wright, was investigating the notion of synesthesia from within the context of virtual reality. So we started off this research endeavor more or less just before we had the pandemic. So we started it off in 2019, 2020, really. And in the UK, we had the pandemic of COVID-19 starting in early 2020. So I am just putting that parenthesis here. I'm opening that parenthesis so that I can give you the context of the timeline for the research that I'm talking about now. Synesthesia, for those of you that are not aware of it, is in effect a phenomenon that occurs in part of our population, where in effect typical, let's say, sensory triggers are manifesting in unexpected situations, in unexpected combinations. I'm just going to be giving you the example that Merter back in 2017 expressed, that in effect the condition synesthesia is where we visualize sounds, we smell words, we taste colors, or touch tastes. So in effect is a fusion, is a different and unexpected, let's say, combination of trigger and experience, of sensory trigger and experience, sensor and experience, more broadly speaking. So why we are interested in synesthesia? Why, for example, we've been looking at synesthesia in VR, in mixed reality more broadly, is because it provides two different aspects to investigate in regards to user experience. And these two different aspects includes the multisensory aspect and the potential to fuse sensory inputs and outputs in novel ways in order to create new experiences. But also it provides another opportunity to test bed, as we say, the notion of unexpectedness. So from other research that I've been doing myself, which was within the context of investigating serendipity, where serendipity is when we have the phenomenon of a happy accident occurring in our lives, something that unexpectedly occurs in our lives that leads to something positive. We know from within this thread of research that unexpectedness can provide innovation, can provide completely novel experiences and connections with others. So thinking about this thread of research that I've been doing, alongside with the multisensory aspect that synesthesia can offer, and we know that it's currently synesthesia is not experienced, is not accessible to the majority of the population. It's just experienced by a small portion of our population. We thought that synesthesia would be an excellent way, an excellent thing to investigate, in experiential aspect to investigate within the context of mixed reality. So what we decided to do was to investigate synaesthetic approaches to virtual reality and how we can marry these approaches to what we call multisensory VR. You don't need to have synesthesia. You don't need to be born with synesthesia in order to experience a synaesthetic approach. So in that way, we wanted to investigate designing or improving virtual reality innovations and mixed reality innovations so that they are accessible to a broader set of people. So, I talked about multimodality as being one of the key things that, alongside with synaesthetic approaches, can actually provide us a sensory fusion that can provide atypical, novel interactions and user experience in mixed reality contexts. So, as I said, when we started off investigating this research, we had COVID-19. So this meant for us in the UK multiple lockdowns, especially where I'm located at Leicester. Leicester actually was one of the cities in the UK that was hit really hard by the lockdowns because of the incidents that we had. And of course, as you may imagine, with the lockdowns, that was translated to no access to our HCI lab in order to conduct our research. And of course, that had a direct, very, very, very strong research impact on the data capture and the research progression that we were aiming for. So we had to think of ways to actually progress with the data collection and with the research in synesthesia and mixed reality. So what we ended up doing was to design remote user studies where we employed virtual environment contexts. We have given to participants virtual environment contexts where they could connect remotely and being participating into our studies to give us data. But we also, through these virtual environment contexts that we have put forward in our studies, we aimed to bridge the gap between the digital, virtual, and the physical. And I'll explain what I mean by that. Overall, what we did was we employed very much a model of similar to escape rooms. So the environment that we gave to our participants involved an escape room setup with a number of different mazes, and a different set of puzzles and a multisensory set of triggers for them to experience as they would progress with the puzzles and activities set for them to do. We wanted to investigate, alongside with the user experience aspects, levels of immersion, emotion levels, and presence. We wanted also to investigate time. So how people felt that time was passing as they were immersed, as they were engaging with the virtuality that we proposed to them. The reason why we wanted to investigate time perception is obviously because we have a lot of literature out there providing data regarding to how time flies or how time is being perceived when people are being given goal-oriented tasks versus when they are being given leisure-based tasks. We also collected not just quantitative data, but also qualitative data in the form of semi-structured interviews so that we can gain some more understandings on how people were feeling when they were immersed, when they were using the environment. So our broad key questions was investigating the effects that different synesthetic elements that have been embedded within the environment have on immersion, levels of immersions and presence. We wanted to investigate what effect does synesthetic approaches to a virtual environment have on user performance, so how people perform in regards to goal-directed navigation. How does a synesthetic approach contribute to experience, more broadly, to user experience and levels of immersion in a virtual context? So we had 20 participants in the first instance. As I said, we exposed them to five different mazes and 5 sets of puzzles. We had emotion survey before and after completed, as well as immersion surveys, and then short interviews over video conferencing. What you can see on the images here are just some snippets of parts of the environment, the first environment that they were exposed to. And as you can see, we did not aim to actually make it very, very realistic proof, as I would say. We didn't care to actually create a pure simulation of what a typical environment would be. For us, the key thing was, in this first instance, to test the multisensory aspect and test goal directedness within a virtual setting. So we were hypothesizing that high levels of immersion in participants would lead to improved problem solving and faster navigation. We also hypothesized that higher levels of immersion would lead to higher levels of change blindness. And I would like to note here that change blindness refers to when users of a virtual room do not do not perceive changes that are happening within the environment. The reason why we wanted to look at that is because change blindness obviously is directly relevant to attention and to the way that we process information and solve problems as well. We wanted to also, we hypothesized that participants who actually notice the changes made in the environment would have a more enhanced user experience in regards to maze narration. So with the way that we have manipulated, let's say, the environment in our case was in terms of colors. So we have been manipulating the colors of the maze walls. We have been manipulating the narration, therefore the auditory input that people were exposed to when they were immersed into the environment. We also manipulated the audio through the provision of audio coming from windows in the form of bird songs. We have also utilized locations. We have included within the environment stairs so that people can navigate at different aspects, different levels, and include also doors where people can go through and navigate across different rooms. We also included, of course, Windows views, and again, we manipulated wall colors in the puzzle rooms, where you can see here on the table PR, this corresponds to puzzle rooms. So within the environment, we had areas that involved puzzle rooms where people would need to complete a puzzle that was similar to what you see on the right-hand side image here with the colored buttons, but we also had rooms that they were just about navigating and exploring the area. First of all, as part of designing the environment, of course, we've produced designs in 2D formats, as you can see in the image here, where we highlighted, in effect, we demonstrated the blueprint of the environment, and then Victoria has created a 3D version of the environment using modeling software Blender to actually create this more immersive experience. We had a combination of different age ranges. The average age was 36 years. We had people that had already experience with playing games, but also we had 7 of the participants that they were not video game players. And the reason for trying to gain experiential data from both groups was in order to identify differences between, let's say, more expert groups as opposed to novice groups. In effect, we want to see whether the multisensory and synaesthetic approaches creates any differences in the experience between video game players and non-video game players. We didn't find any correlations between immersion levels and emotions and the age or gender of individuals. So we found that non-players, novice, let's say, people, felt their senses were engaged more compared to people that have experience playing video games. So in effect, that's something that can give us information about expertise, let's say, and acclimatization to pieces of technology that have not been used before. Non-players also felt involved in the visual aspect of the environment. Again, that might be because of familiarity aspects. So people that are familiar, they are players of video games that involve virtual environments, are used, and therefore the level of immersion perceived is faded, let's say, compared to the non-players that they have not had experience previously. Non-players felt involved in the auditory aspect of the environment. So, for example, in the narration, as I said, when people were exposed to the virtual environment, there was narration as an auditory trigger incorporated within the experience. And again, non-players felt the sense of moving around the virtual environment more compelling compared to people that do not play games. So what these can tell us is that actually we have a different experiential sensory preference and perception in terms of immersion between people that they are not typical game players compared to those that are. That's something we need to keep in mind, especially if I go back to the COVID-19 context. This is very important to keep in mind, because as you all know, during the pandemic period, a lot of the teaching sessions, learning sessions that we've been running have been happening remotely. So in effect, all students, all people that they were exposed to learning experiences had to be using virtual environments, had to be using remote collaboration platforms. The fact that we identify that certain groups of people appear to be having completely different sensory engagement and perception compared to those that they are more experienced in using such environments, it suggests at least that we need to be careful of accessibility. We need to be careful of how we can design technologies that are fair, provide fair experiences to everyone based on what prior experience they have. Moving on, we've seen an increase in levels of surprise, of the unexpected aspect. And that was very much associated to design features that we embedded, such as the auditory features, birdsong narration. So in effect, this suggests that people that have been experiencing the auditory aspect reported as well an increased level of surprise. Somehow, in virtual settings, hearing can be more surprising compared to seeing. That's again something quite interesting for us, especially within the context of learning. Because again, I'll go back to the COVID-19 context, where everyone had to be using remote platforms and virtual contexts. It's very important to see or to investigate which is the most optimal sensory trigger that can actually promote different experiences. The reason why the element of surprise here is interesting, because surprise can be associated to attention, can also be associated to memory. And we all know that within the context of learning, attention and memory play key roles in performance. We've also seen an increase in levels of pride and being inspired. The notions of pride and inspiration and surprise are part of the emotional and immersion surveys. So we've seen that non-video gamers had a more positive change in inspired experiential contexts compared to those who play video games. We also seen that non-video gamers had a more positive change in emotions compared to those that they play video games. I'm just providing you here an example of a quote from a participant saying that it worked quite well for me. So I had more of a sense of wow, I've done it, you know, of achievement. So it does get your emotions quite going, certainly. We've seen a decrease in levels of interested and enthusiastic. These were comparisons made between the commercial video gamers and those that they are not video gamers. So in effect, we are seeing a different kind of response, emotional response, between experts and novices. Again, that's something that it can be expected at to an extent because it is related to familiarity. People that are familiar to an environment might not be as enthusiastic as opposed to others that they have not been exposed to such environments before. Now, we had a number of key feedback in regards to the auditory aspect. For example, bird songs. It was very powerful, uplifting, pleasant. Immediately, it made participants think that actually there is something out there, you know, something outside the room. And I found quite interesting cases like the one that I present you here, where participants said that the auditory input, the bird song was warming to the senses. Landmarks that they were also located visually within the environment, the virtual environment, were considered to be helpful, but also were actually considered as mediators for giving some sort of life to the environment. So this kind of feedback give us understandings in regards to what realism plays, what role realism in the design of environment plays into the experiential aspect. So we found a number of positive correlations between the visual aspects of the environment, but also the auditory aspects of the environments. And also, we have found a positive correlation between the perceptions of positive emotions and the perception of time. Speaking of time, what we found was people felt that they spend more time, longer time. They miscalculated, in effect, the amount of time that they thought they spent when they were immersed within the environment. And that actually contradicts with other research that exists within the literature. That was a very interesting aspect for us to investigate. And in regards to the change blindness, as I said, we had change blindness that was related to physical aspects of the environment, such as we have been moving doors, we've been changing the windows views and the wall colors. And we also had another additional change in related to audio, where the narrator was different between two mazes. So you can see here some examples of the change blindness that we have been embedding within the design. So again, we've been identifying positive correlation between visual changes and how people perceived, how well they perceive that they have actively investigated, searched the environment. But we found a negative correlation between the audio change and how much the participants perceive the visual aspects of the environment involving them. It's interesting to note here that people have also responded and reported that, they were switching between sensory triggers. So as soon as another sensory trigger came into play, people were switching, their attention was diverted, and that had a result to overpower the other sensory inputs. That's, again, extremely important when we are thinking about learning contexts, especially within learning contexts and where we use virtual contexts, virtual environments. We need to think carefully how the users switch between different modalities, how they switch between different inputs. That is extremely critical also for applications where critical training takes place through virtual environments. So as I'm moving towards the end, the second study that we've done, which was again under the context environment, was incorporating this time physical sensory props that were sent to participants, and participants were guided, they were guided to actually include them as they were experiencing the virtual environment. We've also incorporated augmented reality puzzles in this case, again, as a means of bridging the gap between the virtual, the physical, and the digital. And here you can see some examples of the props, the physical props and the augmented reality props, the one that you see on the right, that we've used in this study. This was very much the notion of incorporating physical props in the experience of a virtual environment was very much triggered by some of my previous research as part of the Creativity Greenhouse project, which was an EPSRC funded project, where in effect, what we've done, we've been facilitating remote, collaborative, and competitive platform to people that they were bidding for research funding. So the context of this study was to get groups of people, teams, work together remotely using the virtual environment to compete, to collaborate with each other and compete, come up with ideas, in effect, funding ideas, so that they can get funded. They would need to use the virtual environment for a week, working full-time every day on the bid. And what we tested bed in that project was to use physical props in order to promote creativity, promote relaxation, acknowledging that spending time within a virtual environment full-time for a whole week can be exhaustive, and of course to promote better performance. This is an example of the physical prop that we had used in the Creativity Greenhouse project, which was very much inspired by the Japanese bento box. And the box involved the props and the rules on how to use them. So you can see there was a combination of different physical props and information given to participants as they were utilizing, as they were using the virtual environment. And in effect, this is what we tried to do as well in our Synaesthetic-approaches in VR project. So similar props were sent to participants where we highlighted different sensory triggers being part of those of the physical props. And we also asked participants to complete immersive tendencies and vast emotion surveys before and after their exposure to the virtual environment. What you can see here is an example of our physical prop, where you can see it included lollipops, biscuits, activities, tea as well to drink, as people have been immersing into the virtual environment. We found that the synesthetic group of participants, those people that they were exposed to a combination of sensory triggers, reported stronger feelings of presence compared to the control group. In regards to the different mazes that we've incorporated in the environment, where we had 3 mazes, we had a mystery maze, we had an escape maze, and we had a tutorial maze. We've identified that stronger presence was reported in the mystery and escape mazes compared to tutorial. And also we've found that the escape maze triggered more presence compared to the mystery. this is a still ongoing data analysis, which is informing a third study that we are currently planning. As a conclusion, I would like to point a couple of insights that we found as part of running these studies during COVID. We need to enrich the environment with multimodal triggers because that relates and affects user experience. We need to be careful on how we do that because we don't want to be confusing users in regards to the triggers. We want, there is a threshold of fusion that needs to take place in order to produce a positive user experience. That's what we want to be exploring in the third study that we are running now. We found that that multimodality and the sensory fusion can have direct implications on remote learning and fatigue. Capability to search, monitor, and move within the environment is related to naturalistic design and interaction. So VR design needs to take into account more multimodal sensory input, because that's one of the ways to produce more naturalistic design and interactions. And we've seen within AI technologies that this is one of the key things that we need to be doing. Naturalistic, for example, chatbots are very much on the hype right now because of this naturalistic layer of interaction. That's something that in mixed reality we need to also further explore. That naturalistic aspect has implications on the comfort and trust that users have with these technologies. And within the context of remote learning or remote data collection, that's absolutely key to the validity of the data that we collect through virtual environments. We need to have a balance between the unexpectedness and the mix of sensory triggers, because negative emotions can emerge if there is an imbalance. Multimodality can support, we found that multimodality actually can support novel design approaches for mixed reality. We found that a complicated virtual environment is not required to distract most participants. Notions of escapism are appreciated in virtuality, especially when, from the feedback that we got from participants during the pandemic. Mixed reality could be offering breaks from routine work. And that is an interesting thing to explore right now, especially given that the pandemic has gone, the lockdowns are off, because as we know, during the lockdowns, we had to work within virtual contexts continuously. So it's interesting to see that switching and transition back to part-time, let's say, virtuality. One of the key things that we have identified is the sensory dominance. And that's something, as I said before, earlier, it's critical for remote learning, because we want to understand the users that are engaging with virtual contexts, and identify their individual differences, actually, because they can display different sensory dominance when they're engaging with such an environment. And that can have direct implications on their performance, on the task performance. And we've seen that time flies, actually. Participants overestimated the time spent, contrary to existing research. Fusing physical and digital with digital and virtual can create a layer of togetherness and a stronger sense of connection between the two worlds. That's something that people have expressed in their qualitative data. And they have also highlighted the aspect of breaking immersion. And breaking immersion in VR is not necessarily something bad. That's something that we found out and we want to further explore in our future research. To conclude, it seems that multimodality and synaesthetic approaches are related to human cognition. such as attention and perception of time. These are critical aspects, especially when we are designing applications, VR applications for special missions, for example, space research. Kinesthetics are critical as well. So how we move within the space, in effect. And that can have a direct impact on fatigue levels. Fuse design through synaesthetic approaches can offer opportunities for improving UX and performance more explicitly. And lastly, from our experience of running remote virtual studies, there is a great need for stronger coordination and monitoring of the participants. First of all, in order to safeguard them from unexpected effects. I mean, VR can have, and immersion in virtual environments can have some side effects, but also in order to safeguard the validity of the execution of the required tasks. We need to always keep in mind the older populations as well, and those that they are not used to virtual reality technologies. We don't want to be creating inequalities, both in experiences, but also in the way that people perceive those technologies. Thank you very much. We have a number of publications you want to look through that are related to the talk that I've given, and I'm happy to answer any questions.
Thank you. Thank you very much for the amazing presentation. It's really, really exciting work. And I mean, I had a lot of notes I would like to ask, but I think we have a couple of questions from the chat. So Lydia asked, how did you measure the level of surprise? By number of unexpected objects?
Yeah, so what we've done, the level of surprise was part of the surveys that we have given to participants before and after. And the way that we have been manipulating the surprise was both in regards to the physical visual triggers, so change blindness, or that was one. The other one was in regards to the auditory manipulation, so whether people have felt surprise by the auditory triggers that they were receiving, but also through the semi-structured interviews that we had afterwards, we had opened up the question to more broadly to participants to actually discuss with us anything that they felt was unexpected. This, and that went beyond the physical manipulation, the manipulation that we've done within the environment. So we have both quantitative data and qualitative data in regards to the surprise.
Okay, thank you. There's another question, but I'm just conscious of time. So maybe we can have just a very quick review to that one. Could I ask you to clarify the results on perceived time? What did you find? How is it different from previous findings?
So perception of time was found to be different from other studies in the sense that people miscalculated the way that they felt they were in the environment. So for example, in our studies here, we found that people were feeling, perceiving that they were spending, that they had spent longer time within the environment. In existing research, what we've been seeing in environments like similar to the ones that we've been exposing our participants, they've been finding the opposite, that actually people were finding that they had spent smaller amount of time compared to the one that actually they spent. So in effect, we didn't see the same perception of time in our research compared to what is being reported in literature. So we didn't see alignment between actually alignment with the findings that we currently have in research about time perception. I don't know if that explains it. So in effect, we've seen that more people, I don't know if I can go back to the graph here. So in effect, what we found is that people in our study perceived as spending longer time within the environment compared to the real time. Mm. And that is something significant. We've seen this is a significant result, and we've seen it occurring across almost all the participants that took part. In current research, we see the opposite, that actually the real time is longer than the perceived time that people expressed in other similar studies. Mm. So we reckon that this might be because of the manipulations, because of the multisensory aspect that we've been manipulating in our studies.
This is really fascinating. Yeah, Lydia says, thank you. This topic of perceived time seems really tricky. So it is, but it's also fascinating topic. So I just want to thank you again, Genovefa, and please, everyone, thank you if you can, with clapping hands if you can. It was really pleasure to have you. So thank you again, and
thank you very much.